Hello everyone and welcome to our today's class. It is our fourth lesson on the topic thermal expansion. So before we begin, let me start by giving you the quote of the day, which states that sometimes we are too busy complaining about the small things we don't have in life to the extent that we forget to cherish the big things that we already have in life, such as the gift of life, good health, peace of mind, etc. So today we are discussing about expansion of gases. So we already defined what we mean by expansion. So in our previous lessons we looked at expansion in solids and liquids. So today we are looking at expansion in gases. So this is an experiment to demonstrate expansion in gases. The apparatus required, one is a round bottom flask, round bottom because the bottom is actually circular or round. Then the other apparatus that we need, we will need a glass tube, we'll also need a cork, we'll also need a beaker, and a beaker filled with some water. So in this experiment, the apparatus are arranged as shown in this diagram. That is, we take a round bottom flask, we cork it with a glass tube in position, then we dip it in water or any other relevant liquid. Then you warm the round bottom flask by using your hand or any other relevant source of heat, for example a Bunsen burner. You warm it slightly and observe what happens. So when the round bottom flask is warmed, it is observed that the level of the water in the glass tube drops slightly. Now, why does the level of the water drop slightly when the glass is warmed? This because, remember, inside the round bottom flask we have air. So whenever you heat air, it will always expand. So the level of the water in the glass tube drops slightly because when the round bottom flask is warmed, the air inside the round bottom flask expands. So when it expands, it means it needs more space, because to expand means the volume has increased. So the water is pushed downward so that the expanded air gets the enough space, that is the increased space as a result of expansion. So what causes the level of the water in the glass tube to drop slightly is because of the expanded air inside the round bottomed flask. Now when the supply of heat is continued on the round bottom flask, that is when there is more heat supply, soon bubbles will be seen escaping from the glass tube through the water. So when heat supply is continued, we expect bubbles will be observed escaping from the flask, the glass tube through the water. Now why does the bubbles appear? So these bubbles represent air which has expanded, that is escaping out of the glass tube. So the bubbles form showing that actually there is expansion of air which is escaping from the round bottom flask or the glass tube. Then when the round bottom flask is cooled, it can be cooled by either pouring on it some cold water or just leaving it disconnected from the source of heat, then it will cool. So on cooling, it is observed that the water in the glass tube rises upwards. Now why does the level of the water rise upwards on cooling? Remember, cooling is accompanied by contraction. So when the round bottom flask is cooled, the air inside the round bottom flask contracts, therefore reducing in size. So if it contracts, it means there is an extra space that has been created inside this round bottom flask. So the water rises up to fill that extra space that has been created due to the contracted air. So when the air contracts, it means there will be a partial vacuum inside this round bottom flask, that is a place not filled with air. So the water rises up because of the contracted air, or to fill the space left by the contracted air. So in this experiment, you need to know the expected observation. One is that when the glass flask is heated, the level of the water in the glass tube drops slightly. Why does it drop? Because of the expansion of air. Then when there is continuous heat supply, bubbles will be seen escaping from the glass tube through the water. So the bubbles escape because of air has expanded, therefore the excess air is escaping in form of what? Bubbles. Then when the glass flask, the round bottom flask is cooled by either pouring on it some cold water, it is observed that the water level in the glass tube rises upwards. Why does the level of the water rise? Because cooling means that the air inside the round bottom flask cools, therefore contracts. When it contracts, there is an extra space that will be left there, so the water rises up to fill the space left by the contracted air. So we can also look at molecular explanation of expansion. Molecular explanation of expansion. So we'll discuss various states of matter. So in solid state, we did say that the particles are closely packed together. Why? Because there are stronger intermolecular forces, that is the cohesive force or force of attraction between molecules of the same kind. So in solids, the particles are closely packed together because of the stronger cohesive forces between any two solid particles. So when a solid is heated, the particles vibrate but at fixed positions. So remember, vibration means they move side by side, although at the same position. So those movement, it means the intermolecular distance between any two particles will slightly increase. So when the distance increase, it means the volume has increased. Therefore, we say that the solid has expanded. We say that the solid has actually expanded. So expansion in solids is actually very slight, or it is smaller as compared to liquids and gases. Why? Because of the stronger cohesive forces between the solid particles, such that particles do not move away from each other because of the stronger cohesive forces or force of attraction between the solid particles. Now in liquids, the particles are slightly far away from each other. That is, the particles are far away as compared to solids. This because in liquids the intermolecular forces are weak, that is the cohesive forces between any two liquid particles, they are weak. Therefore, it means that the particles are actually slightly far from each other. Now when a liquid is heated, these particles gain kinetic energy. Remember, kinetic energy is the energy in motion. So when particles gain kinetic energy, it means now they have the ability to move away from each other. So when a liquid is heated, the molecules or the particles within the liquid actually gain kinetic energy, therefore move away from each other. As they move away from each other, it means they are increasing the intermolecular distances between any two liquid particles. So when the distances are increasing, it means the volume is increasing. And remember, an increase in volume, that is what we call expansion. So an increase in volume or the intermolecular distances increases when the particles gain kinetic energy, therefore expanding, leading to an increase in volume or expansion. So it is important to note that expansion in liquids is more than in solids. Why? Because of the weaker cohesive forces between the liquid particles as compared to the solid particles. Now when we come to gases, in gases the particles are already far away from each other. That is far as compared to in liquids and even in solids. So in gases the particles are further away from each other because of very weak intermolecular forces between any two gas particles. So the cohesive forces between any two particles in gaseous state is actually very weak. The forces are very weak such that particles are away from each other, meaning that the intermolecular distances between any two particles are larger. Now remember also that now when a gas is heated, remember that heating means that the particles are gaining kinetic energy. So kinetic energy is the energy in motion. So when particles are heated in gaseous state, they gain more kinetic energy, therefore moving further away from each other. So as they move further away from each other, it means they are increasing the intermolecular distances between any two particles. Therefore, when the intermolecular distances are increased, it means the volume is also increased, and therefore we say that the gas has expanded. So we are saying that expansion in gases is more than in liquids and in solids. Why? Because of very weak cohesive forces between the gas particles, because of the weak cohesive forces between the gas particles. So we can also look at what we call a measurement of temperature. Now we need to understand the instrument used for measuring temperature. So we look at what we call a thermometer. So we need to define it. Now what is a thermometer? So a thermometer is an instrument or a device used for measuring temperature. Now there are various types of thermometers, but there are three main categories. We have what we call the liquid in glass thermometer. We have what we call the 6's, maximum and minimum thermometer, and lastly we have what we call the bimetallic thermometer or the bimetallic strip thermometer. So each thermometer is used according to the specific measurements required. So we'll discuss the liquid in glass thermometer. So as the word suggests, it means the thermometric substance here is a liquid. The liquids mostly used is usually mercury and or alcohol, either mercury or colored alcohol. We'll see why mercury and not other liquids, for example water. So what are the characteristics of a thermometric liquid? So what is a thermometric liquid? A thermometric liquid, this is a liquid that is used in a thermometer. That is, it is placed in the bulb, whereby when the temperature increases, the liquid also expands, thereby recording some reading. So that is what we call a thermometric liquid. So what are the factors to consider before selecting a thermometric liquid, or what are the characteristics or properties of a thermometric liquid? So a thermometric liquid should have these four properties or characteristics. One is that it should be easily seen or easily visible. It should be easily visible. Two is that why should it be easily visible? So that the person recording the measurements can easily see it. You cannot use a colorless substance close to something like water. So that's why we prefer using either mercury, because mercury already has is colored, then or colored alcohol. So one of the characteristics or properties of a thermometric liquid is that it should be easily visible. Two is that the thermometric liquid should have a wide range of temperature. It should have a wide range of temperature. What do we mean by a wide range of temperature? So a wide range of temperature means that the thermometric liquid should have a very low either melting or boiling point, and it should also a very low melting or freezing point, or it should also have a very high boiling point. So wide temperature means that the values between the melting point and the boiling point, or the values between the freezing point and the boiling point, should be many. So to increase those values, it means that the liquid should have a very small melting point and a very high boiling point, so that it can record temperatures of even when temperatures actually drop to negative, and it can also record temperatures, very high temperatures of maybe greater than 100 degrees Celsius. So the liquid should have a wide range of temperature. Then the third property is that the thermometric liquid should not stick on the glass, or it should not wet the glass being used. So that's why we don't prefer using water, because water in most cases will wet the glass tube. So the thermometric liquid should not wet the glass tube. Then the fourth one is that the thermometric liquid should be sensitive to small temperature changes. It should be sensitive to small temperature changes, and it should also it should also expand and contract uniformly. So the thermometric liquid should expand and contract uniformly and be sensitive to small temperature changes. Then we look at properties of thermometric liquid. So the commonly used thermometric liquid is alcohol and mercury. So we are comparing their properties here. So clearly you can see that alcohol has a low boiling point of 78 degrees Celsius. Then mercury has a high boiling point of 357 degrees Celsius. So what simply means is that it shows that actually mercury is preferred for measuring higher temperatures, for measuring very high temperatures, because it can measure up to 357 degrees Celsius. Then alcohol has a melting point of negative 115 degrees Celsius. So but mercury has a relatively high melting point of negative 39 degrees Celsius. So what this simply means is that alcohol is appropriate for measuring temperatures, very low temperatures. That's why we prefer using alcohol as the thermometric liquid in Arctic regions. Arctic regions, remember, these are the North Pole, where the temperatures are very low. Actually, there is very high freezing. So an appropriate thermometric liquid for use in Arctic region is the what we call the colored alcohol, or simply the alcohol, because it has a low freezing or melting point. It has a low freezing point. Then we can also see that alcohol has a poor thermal, it is a poor thermal conductor. That means its conductivity of heat, remember thermal means heat, then conductor is from conduction. So alcohol is relatively a poor conductor of heat, unlike mercury, which is a good thermal conductor. So that means that mercury will always expand and contract uniformly and with a wide range, even with small changes in temperature. Then alcohol expands slightly irregularly. It expands slightly irregularly, but mercury expands regularly. So remember, we've said that one of the properties of thermometric liquid is that it should expand and contract uniformly. Then alcohol, to some extent, it wets the glass, but mercury does not wet the glass or does not stick on the glass walls. Then we have alcohol is transparent or has to be colored to make it easily visible, whereas mercury is opaque and silvery. So that means mercury does not require coloring for it to be visible, unlike alcohol, which has to be colored. So a common question here is usually that explain why alcohol is preferred for use as a thermometric liquid in Arctic regions. So the reason is because it has a low freezing point. Therefore, it means it can record very low temperatures. Remember, in Arctic regions, that is where you have very low temperatures, actually below 0 degrees Celsius, below 0 degrees Celsius. Then lastly, we can look at the temperature scale, that is the upper fixed point and the lower fixed point, the upper and the lower fixed point. First of all, we need to know what we understand by the temperature scale. So a temperature scale simply means it is the scale of a thermometer. So a thermometer usually has a temperature scale. In most cases, it will run from maybe 0 up to 100 degrees Celsius. So the temperature scale is obtained by first determining 2 points, which we call the fixed points. So these fixed points, we have 2 of them. We have what we call the upper fixed point and the lower fixed point. So first of all, we need to differentiate them in terms of definition. Now, what is upper fixed point? So upper fixed point, this is the temperature of steam boiling at normal atmospheric pressure. The temperature of steam above water boiling at normal atmospheric pressure, that is of 760 millimeters of mercury. So we are saying that upper fixed point is the temperature of steam above water boiling at normal atmospheric pressure of 760 millimeters of mercury. Then the lower fixed point, this one refers to, is simply the temperature of pure melting ice. Lower fixed point is the temperature of pure melting ice. Now, there is a question that is usually asked here. When we are determining the upper fixed point, we usually use steam and not water. Why do we use steam and not water when determining the upper fixed point? This is because steam, water could contain impurities that could higher the boiling point. Remember, impurities will always higher the boiling point of a pure substance, and they will always lower the melting point of a pure substance. So if you are asked to give a reason why in determining the upper fixed point steam and not water is used, so it is because water could contain impurities which could increase the boiling point. Then another question can also be asked, why do we use ice in determining the lower fixed point and not water? So the same reason. This is because water could contain impurities that will lower the melting point, because water could contain impurities that will lower the melting point. So here is a demonstration of how a temperature scale is determined. So we have here, so a thermometer is taken and dipped into melting ice. Remember, we know that ice will always start melting at 0 degrees Celsius. So we dip the bulb of the thermometer in melting ice as shown in this diagram. This is melting ice. We have our thermometer here. So the temperature recorded while the thermometer is dipped into melting ice, that is what we call the lower fixed point. In most cases, we take it as 0 degrees Celsius. Then to determine the upper fixed point, we dip the bulb of the thermometer in steam. This is steam actually. So we know that the temperature of steam in most cases will always be 100 degrees Celsius. So the value of the temperature obtained from this thermometer when it is dipped in steam, this is what we call the upper fixed point. After determining the two fixed points, we simply divide the values remaining appropriately. So for example, assuming our highest temperature, our upper fixed point was 100, then our lower fixed point was 0. So we simply, you take this length 100 up to 0, then you divide it appropriately such that each division maybe represents 10 or even 1. So you first of all determine the lower fixed point, you determine the upper fixed point, then you divide by the number of divisions that you want, then you obtain your scale here, you obtain your scale as shown in this diagram. Now we've come to the end of our class today, and therefore we want to discuss the quote of the day, which simply stated that sometimes we are too busy complaining about what we don't have to the extent that we forget to cherish the small things that we already have in life. What does that quote mean? The quote means that you should practice to see gratitude in life. Appreciate the small things. There are people outside there who don't even have the eyes. They are not blessed to have the legs to walk. They are not blessed to have the food that you already have on your table. So learn to appreciate the small things that you already have. Stop being a complainer in life. It is usually said that the world is full of people who like complaining but do nothing about that problem. So please, don't join the queue of complainers. Be a problem solver. Be a problem solver. This is Kind Tuition Academy. Hit that subscription button on YouTube. Kind Tuition Academy. Thank you.